In our last episode, we were working on sum and difference formulas for sine and cosine, and it was getting a little long, so I cut it off before we got to tangent. There actually is one more sum and difference formula, and that's for tangents. And it's one that we don't use all that often. It's just kind of a nice thing to know that it's there. Remember in that last example, we had figured out that we could actually find the tan of a minus b by simply finding the sine of a minus b, cosine of a minus b, and then dividing them. But, that's not always efficient. If you have information about the tan of a and the tan of b, you can actually find the tan of a minus b. So here's how the two formulas work. They don't need to be memorized. I will give you the formula sheet that contains these on the test, and in fact, I'll show you the formula sheet in a minute. So the tan of a plus b is the tan plus tan over 1 minus tan, and then tan of a minus b is tan of a minus tan of b. The difference on the bottom is that it's addition instead of subtraction. So how do these things work? Well, let's go back to the example that we had from the end of the last slide and try the tan of a minus b, and then we'll compare answers. So this was a slide that we had. I cleaned it up a little bit. We had a sine negative 7 over 25 in quadrant 4. Cosine was 4/5 in quadrant 1. And so if you remember up in the top right corner, we had drawn a couple of triangles, right? Quadrant A, angle A in quadrant 4, angle B in quadrant 1, and we filled everything in. We had a cosine and a sine. So if we took opposites and adjacents, we could get ourselves a tangent. And so for triangle, the first triangle with angle A, tangent is opposite over adjacent. So the tan of angle A is opposite over adjacent. The tan of angle B, again, opposite over adjacent, so 3/4. So what does our formula say? It says the tan of A minus B is the tan of A minus the tan of B over 1 plus tan A tan B. So this is going to involve a little bit of fraction work because the denominators are not the same, right? Tangent of A is negative 7 over 24. Tangent of B, right, is 3 over 4 over 1 plus the tan of A times the tan of B. Okay, up on the top, I got a 7 over 24. That's a minus in between, minus 3/4. Common denominator, we're going to have to use 24. So let's multiply top and bottom here by 6. And so I get negative 7 over 24 minus 18 over 24, which gives me negative 25 over 24. All right, down the bottom, I've got a negative 7/24 times 3/24. I can actually simplify this a little bit first if it makes it any better. Let's see. So I can knock a 3 out of top and bottom here, and that will give me 1 and then minus 7 over 32. Well, this 1 is the same thing as 32 over 32. So I got 32 over 32 minus 7 over 32 is going to give me 25 over 32. So how does this work? We take the top fraction and multiply by the reciprocal of the bottom fraction. And when we do that, look at that. The 25s cancel top and bottom. I end up with negative 32 over 24, both of which are divisible by 8. So 32 divided by 8 is 4, or negative 4. And 24 divided by 8 is 3. So using this tangent formula, I get negative 4/3. Let's go back to the previous slide and see if that's what we got when we did it by taking a sine and dividing it by cosine. We got negative 4/3, right? Right down the bottom in red, negative 4/3. So if we had the sine and cosine already for the difference, then it's easier just to divide them and get the tangent. But you notice that for these, if all I had was information about the tangent, I could still find the tangent of A minus B. And again, this is not something that has to be memorized. It's just another formula that we can use to find information. All right, let's try this one. This one is about secant and sine. We haven't done ones with secants and sines. Let's try it. So secant is 13/5 in quadrant 4. So remember, secant is the reciprocal of cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. All right, so here we are in quadrant 4. Secant of angle x is hypotenuse over adjacent. Either use the Pythagorean theorem or remember that this is a 5, 12, 13 triangle. That's got to be -12. All right, in quadrant 1, it says the sine of angle y is 3/5. Sine is opposite over hypotenuse. And again, Pythagorean theorem or Pythagorean triple to identify that as 4. So if I want to find the sine of x minus y, this is the one that goes sine, cosine, cosine, sine. So sine, cosine, minus cosine, sine. All right, so now I got to make sure I match up the right variable with the right angle. So the sine of x, sine is opposite over hypotenuse, so opposite over hypotenuse. Now I got to go over to the second one for the cosine of y. So use that second triangle. Cosine is adjacent over hypotenuse, so adjacent over hypotenuse. All right, the cosine of x. So again, cosine is adjacent over hypotenuse, but remember the right one. So the first one, adjacent side is 5, hypotenuse is 13. And then for the sine of y, sine is opposite over hypotenuse. So I get -48 over 65 minus 15 over 65 gives me -63 over 65. Okay. One thing you'll notice is that the answer is not less than -1. Even though these are signs of differences of angles, sine and cosine can't be greater than 1 or less than -1. So if you're doing one of these formulas for sines and cosines and you're getting numbers that are above 1 or below -1, then something went wrong. Go back and check your work. All right, I think there's one tangent problem that I left out. Here it is. So I've got the tan of pi over 5 plus the tan of 4 pi over 5, and you can read the bottom through. I want to evaluate this. So this is going to turn out to be a number. Which formula does this match with? Well, look at the plus on the top. It must be the plus formula, right? Because the tan of a plus b, tan a plus tan b over 1 minus tan tan. And sure enough, this is tan pi over 5 plus tan 4 pi over 5 over 1 minus tan tan. So this is the tan of pi over 5 plus 4 pi over 5, which is the tan of 5 pi over 5, which is the tan of pi. And then what's the tan of pi? Well, sorry for the boring, but the tan of pi is just 0. So this whole thing is just 0. All right, and that wraps up the sum and the difference of tangents. And actually the sum and difference of cosines too. The next one we get into is double angle formulas. So I'll show you what's in the formula sheet that you're going to get. So it's posted up on Canvas. You can take a look at it. It looks like this. Formula sheet for 5254. Notice that the first set of formulas is sum and difference of tangents. Double angle formulas for sine and cosine you're going to have to memorize. Here's the double angle formula for tangent. There's half angle formulas. There's a power reducing formula for tangent. Again, you're going to have to know the power reducing one for sine and cosine. Product to sum and sum to product. They're nice, they're interesting, but we don't use them a whole lot. Here they all are. And when you take the test and when you take the final, you'll get a copy of this formula sheet. So look to see what's on it, look to see what's not on it. Not every formula is on it, but the ones that we don't use as often are on there. All right, let's take a look at double angle formulas. Double angle formulas you will use a lot, either in this course or in future courses. Calc 2 is especially a place where you're going to use double angle formulas a lot. So suppose I want an expression for the sine of 2x. Well, the sine of 2x is the sine of x plus x, right? X plus x is 2x. So how does the sum of sines work? Well, it works sine, cosine, plus cosine sine, except you notice that instead of doing a sine of x plus y, it's the sine of x plus x. So the variables are all the same. Sine x cosine x plus sine x cosine x. It's the same thing. Doesn't matter what order you put the sine and the cosine. So I get 2 sine x cosine x. And that's the formula for the sine of 2x. So the sine of 2x is the same thing as 2 sine x cosine x. You can find the formulas for the cosine of 2x and tan of 2x in sort of a similar way, in that the cosine of 2x, you can think of it as cosine x plus cosine x, which then gives you cosine minus sine. And so this gives me a cosine squared x minus sine squared x. Cosine of 2x is kind of unique in that it's got multiple representations for what we can do with the cosine of 2x. So here they are. The sine of 2 theta, 2 sine theta, cosine theta, we use that a lot. The cosine of 2 theta, we can write it as cosine squared minus sine squared, but then we can also take various trig formulas and substitute them. So we can replace that cosine squared with a 1 minus sine squared, minus another sine squared gives us 1 minus 2 sine squared. So we can use this formula over here for the cosine of 2 theta, or we can replace it in the other direction, and we can use 1 plus 2 cosine squared theta. There's also a tan of 2 theta, not used nearly as often. There's the formula for it. You'll have it on the formula sheet if you need it for something, but we use the sine of 2 theta and the cosine of 2 theta a lot more often than we use anything with the tan of 2 theta. All right, so look at the first one. It says, let's find exact values for 2 sine 15 cosine 15. So this is the formula 2 sine theta cosine theta equals the sine of 2 theta. So if my thetas are 15 degrees, then this equals the sine of 2 times 15 degrees, which is the sine of 30 degrees. And then I just, on my unit circle, what's the sine of 30 degrees? 1/2. All right, this says 1 minus 2 sine squared of 67.5 degrees. Well, this looks like a cosine formula. Cosine of 2 theta equals 1 minus 2 sine squared theta. So cosine of 2 theta equals 1 minus 2 sine squared of theta. So this is the cosine of 2 times 67.5 degrees. So the cosine of 135. Second quadrant, cosine is negative, so it's got to be negative root 2 over 2. All right, look at the third one. Cosine squared minus sine squared. Again, that's another representation for the cosine of 2 theta. So it's the cosine of 2 times 22.5, which is the cosine of 45 degrees. First quadrant, cosine positive, root 2 over 2. All right, and then we look at that last one down there, 2 cosine squared plus 1. So what formula does that go with? 2 cosine squared plus 1 is the same thing as 1 plus 2 cosine squared. So again, that's the cosine of 2 theta. In this case, our theta is pi over 12. So we get cosine of 2 times pi over 12, which is the cosine of pi over 6. Root 3 over 2. All right, this is just an opportunity to practice with sines and cosines and double angles. It says if the sine is 4/5 and x is between 0 and pi over 2, so we're in the first quadrant here. Sine is opposite over hypotenuse, which means that this piece here is 3. Means I can make myself a list. The sine of the angle was given as 4/5. Cosine of the angle is adjacent over hypotenuse, and the tan of the angle is opposite over adjacent. Okay, so the sine of 2x, what's the formula? 2 sine x cosine x. Well, the sine is 4/5, and the cosine is 3/5, and we just multiply. 2 times 4 is 8, times 3 is 24. 5 times 5 is 25. There's our answer. All right, for the cosine of 2x, we have all different kinds of formulas we can use. We can use cosine squared minus sine squared. That might be a nice one. So cosine squared x minus sine squared x. So cosine is 3/5, so take 3/5 squared minus 4/5 squared. And I get 9 over 25, right, square top, square bottom, minus 16 over 25. 9 minus 16 is negative 7. Is it okay for cosine to be negative? Sure. Why not? All right, tan of 2 theta. Well, we got options for this. We can either take sine and divide it by cosine, or let's try out the formula since we have it. So the formula is 2 tan x over 1 minus tan squared x. So this gives me 2 times 4/3 over 1 minus 4/3 squared. So 2 times 4/3 is 8/3. On the bottom, I get 1 minus 16 over 9. Well, here, can I just turn that 1 into a 9 over 9? And 9 minus 16 is negative 7. So I get 8/3 over negative 7/9, and then we just invert and multiply. Times 9 over negative 7. 8 times 3 is 24 over negative 7. Now, you could try it out with the sine divided by cosine. Right? Take those things and divide them and see if you get the same thing. So here, I'll switch colors so we can see we're doing the same problem in a different way. Take sine and divide it by cosine, so 24 over 25 times the reciprocal of cosine. And you can see those go away, and you get 24 over negative 7. So it doesn't matter if you divide sine by cosine or use the tangent formula. Either way, you're going to get the correct answer. All right, let's do a couple of identity proofs with these things, and then we'll wrap it up. So the sine of 2x secant x equals 2 sine x. It looks to me like we'll start on the left-hand side. Again, we try not to cross the equal sign if we don't have to. The sine of 2x, we got a formula for that. 2 sine x cosine x. And the secant is 1 over cosine. And you see how quickly this ends? We end up with a 2 sine x on this side and a 2 sine x on that side. Problem done. All right, look at the other one, number 2. We got a sine of 2x over 2 sine squared x. So the sine of 2x, again, is 2 sine x cosine x. On the bottom, what does 2 sine squared mean? It means 2 times sine, right? Sine squared is sine times sine. And so the 2's go away, the sines go away, and I'm left with cosine over sine, which is cotan x. All right, so these identity proof problems can be done with double angle formulas. Look at the third one. This is where we have to make a decision what to do with that cosine of 2x. And remember, we've got choices. The cosine of 2x has 3 different options: cosine squared minus sine squared, 1 minus 2 sine squared, and 1 plus cosine 2 squared, or 1 plus 2 cosine squared. Look at what's in the denominator. In the denominator is a cosine minus sine. So my mind says, if I use that cosine squared minus sine squared, then I can factor as a difference of squares, and it'll help me to get to my answer. So let's use the cosine of 2x as cosine squared x minus sine squared x. And now we'll factor that as a difference of squares. So we'll factor it as cosine x minus sine x, cosine x plus sine x. And then on the bottom is still our cosine x minus sine x. You notice these things go away, and what am I left with? Cosine x plus sine x, which is what's on the right-hand side. So choosing the best option for cosine of 2x is what helped me to get my answer very quickly. If I had used one of the other identities, I would eventually get there. It would just take me longer. All right, last one for this video here. We've got cosine minus sine squared equals 1 minus the sine of 2x. Well, I think I have to take that cosine minus sine and expand it. Remember, when you expand it, how does this binomial distribution work? First term squared, 2 times the inside, last term squared. If you don't remember that, you could always multiply cosine minus sine times cosine minus sine and FOIL it through. You'll get the same thing. All right, let's rearrange terms here. If I have cosine squared x plus sine squared x minus 2 cosine x sine x, right? All I did is I moved that sine squared over. Well, cosine squared plus sine squared is 1. 2 cosine x sine x is the sine of 2x. And look, now the two sides are equal to each other. All right, so there's another, that's another example of something you can use the double angle formula for. Right, there are other formulas too, like power reducing formulas, and we'll do the power reducing formulas in the next video.